Hello students, now a series program. Write program to find the sum of the given series. Here you can see students, it begins with 1, then 1 plus 1 upon 2 factorial. This is the symbol of factorial, exclamation sign which you see here. That is meant for the factorial, alright. Plus 1 upon 3 factorial, plus 1 upon 4 factorial, plus dot 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 dot, plus 1 upon n factorial. So n is the end. Here you can see that numerator everywhere is 1 and denominator is changing every time, and you can look at this as 1 upon 1 factorial also, because factorial of 1 is always 1. Student, what is factorial? Right? Factorial is basically the product of all the numbers, product of all the numbers, or you can say positive integers from the number and below that particular number. Means if you want factorial of 4, that means 4 will be included, then 4 into 3 into 2 into 1 means all the positive integers product up to the number, that will be the factorial. Is that clear? So now I'll discuss the program, but first you understand how to deal with the series. First thing, we need a limit, so definitely n will be entered, so n is required. Over there I need to perform the sum, so I have to store the sum somewhere, so I need a variable sum. And you can see the series is having fractions, so that means the sum which will actually going to store the sum of the series will not be of int type, it will be of double type. All right everyone, okay. After that, you look here that different terms are there, 1, then 1 upon 2 factorial, then 1 upon 3 factorial. So basically when you look at this term, so numerator is 1 and denominator is always the factorial of some number, whichever is here. Here it is 3, so 3 factorial, there it is 2 to 2 factorial. So we need a factorial. Every time I add a term, so before adding the term, I need to calculate the factorial of the denominator. So that means there is a main process, that means adding different terms, and there is a sub process where I have to calculate the factorial. So whenever there is a main process to be repeated and there is a sub process to be repeated, I need what? I need nested loop, because repetition is there, so loop is there. But if there is a process and there is a sub process, then I need nested loop. Alright, one loop for addition of all these terms and the other loop which will be the nested inside the outer loop, that will calculate the factorial of the denominator. Is that clear? So in series, what do you need to take care of? Beginning and the end. Then I have to look at the individual terms. So here the terms are fractions, so I have to see what is there in the denominator and what is there in the numerator, right? And is there any relationship between the two consecutive terms? So here you can see that every time we are moving ahead, the denominator is being increased by 1. As I've told you, if anybody asks that there is no denominator, so when there is nothing as a denominator, that means it can be taken as 1 upon 1. So 1 upon 1 factorial, because everywhere denominator's factorial is there and the factorial of 1 is always 1. So I hope everybody is clear, is having the clear idea. So I have to increase the denominator every time by 1, and I have to move from denominator 1 to up to n. Alright, so for input I need the scanner class. So I have imported here util package of the Java package. So import java.util.scanner. So scanner here, students, is there is a class. If anybody writes import java.util.asterisk semicolon, that is also absolutely fine, there is no problem. Students, here you can see that I have written public class series. Series is the name of the class. If you want to use public, that is fine, otherwise you can just have class series, that's absolutely fine. And now the main function, public static void main string args square brackets parenthesis close of the main, then curly braces open. Here we have the logic. Why do we have functions? We have function in a class that will always be having the logic of the program. So here we begin now. Scanner sc equal to new scanner system dot in. This statement is actually what it is doing. It is creating the object of class scanner. After that, student, there is a message on the screen using the system.out.print. What is that? That is enter n. Then enter n. So we have to input the value of the n. So it is written here int n equal to sc dot next int. That is the input statement. Sc is what? Sc is the object of the scanner. Where is the scanner? Scanner is in the util package. So there is always a connection. Keep all these things in your mind. And now sum. This is a very important line. Students make a very common mistake here, that sometimes students write int sum because they are generally having this idea of a normal series, which is the integer one, and they simply write int and they forget that there is fraction in the series. So please be careful while having fractions in the series as terms. So we have to use the double. All right. And after that, second mistake, what do they make? They make that they write in the sum initial value 1. So please avoid that, because here we have to add something. So that is why beginning will always be 0.0. But if there is a product required, then what do we have? We always start with 1. This is a very important thing. Now, as I've told you, in the series we move, denominator is moving from 1 to n. So there is a loop for int I equal to 1. Then I moves up to n. So I less than equal to n. Then I is increased by 1. So I plus plus is here. Then after that, we have to perform what? We have to calculate the factorial. Factorial of what? Factorial of denominator. And denominator we are controlling through this. Alright, that means factorial of I will be calculated. So I need a variable to store the product or the factorial of the number I, which is being denoted through I. So here, students, we need a variable. So I have taken this long f equal to 1 semicolon. Factorial's variable f, the data type choice is long. That is perfect because factorial grows very fast. Factorial grows very fast. So after that, we have a second loop that will have what? That will have students the calculation of factorial. So here it has got for int j equal to 1, then j less than equal to I, j plus plus. It's a very simple factorial loop. You have already done. If you have not, so please do watch my video of factorial. Okay, calculating the factorial of a number. So here the number is I. That is why we have to move from 1 to up to I, and the product of all these values or all these numbers. So here it is inside the loop. What I have to write? F asterisk equal to j, or you may write f equal to f asterisk j. This is the short notation. After that, factorial will be calculated and stored in f. Now this f is basically going to be the denominator for the term. So here it is sum plus equal to 1.0 divided by what? F. F is what? Factorial. This is the short notation again. So you can simply write sum equal to sum plus 1.0 upon f also. That is also fine. Now, why we have not written 1? We have written 1.0 here. Why? Because either numerator or denominator must be of double type, because we need final answer into the double type, because it's a fraction. Because in Java, if you just write system.out.println and you write 1 upon 2, it will always be giving you 0. But if you write 1.0 upon 2, that means it will be typecasted. The answer will be in the double type, and you will be getting 0.5, which is the desired output, which you want actually. Right? This also I have discussed in my previous video. So please do watch my previous videos of series. You'll be having much better understanding of this if any confusion is here. After that, means adding that term to the sum, we move ahead, and then I is increased by 1. So this time I will be 2, then f is reinitialized, that becomes 1 again, and now this time it calculates the factorial of 2. So it will be running, loop will be running from 1 to up to 2. So finally it is calculated, then sum plus equal to 1.0 upon factorial of 2, that will be added. And similarly 3, 4, 5, whatever the limit you have given up to this process is going to be repeated. But remember, the reinitialization of f is a must, because every time I need to calculate the fresh factorial. Alright, and then there is a nested loop. So this is the outer loop, this is the nested loop, and finally that will be added to sum, and after that we print the sum here, right? And then we close the function, and then the loop. Students, after that the output is here, enter n, that is 10, and then finally the sum is printed. I hope everybody has understood the concept well. Thanks everyone.